short demonstration of some of the basic fundamental mathematical aspects of music and musical instruments, which will be followed by a small concert. The instruments that we're going to use in this concert are the string instruments of the viol family, which consists of the violin, the viola, and the cello. Each member of this family addresses a certain frequency range, and these frequency ranges are exploited by composers such as Mozart, Brahms, Bach, to create harmony amongst to create harmony in music. So amongst these, the violin covers the highest frequency range, which is a 196 to 3519 hertz. Rajastha, could you demonstrate? Oh, the lowest note. That's 196 hertz, and the highest. That's 3519 hertz. The viola covers 130 to 1318 hertz. The cello takes on 65 to 1048 hertz. So these are the instruments basically. Now say you have a tune in mind. How are you going to put it on paper? One option is, like say if you came to me and said you wanted to learn violin. What happens if I told you, sorry, if I told you that we're going to play Twinkle Twinkle Little Star, and I gave you this, you'll probably say I'm going to find a new teacher. So this is why musicologists have made a much easier notation using letters of the alphabet, so as not to present such a ghastly experience to the person first learning the violin. So according to this nomenclature of notes, it's named as follows. This is an A, this is a B, this is C, and this is D, followed by E, this is F, G, and then finally E. Sorry, A. Now, I'm not sure if you see my fingers? You can? Should I come in front? When I played A and a B, there's a slight gap between A and B, this gap. You might be wondering what this gap is called. If I take A and go up, say, you can call it a step, I arrive at something called as A sharp. The sharp basically means I'm raising the A by some frequency range. Or I can take B and go back. In this case, I'll call it a B flat. If I take the 8 notes from A, the lower A, to the higher A, what I've done is I've covered an octave scale. And if I cover all these steps, like this is called, basically that step is called a semitone, and what I've done is I've created a chromatic scale. So what you might be wondering is, I call this note an A, I call this an A as well. Our own alphabet consists of 26 letters. Why? So what's the reason behind calling this an A and not something like an H? The answer to this, what we're going to do is now analyze the frequencies of these notes and see if we're going to come up with a reason. So these are the basic sequences that we more or less come across in our school life. The first one is an arithmetic progression. The definition of an arithmetic progression is that the difference between any two consecutive terms remains a constant. In this case, 10, 13, 16, 19, and so on. The difference between terms is the constant 3. Next, we have our geometric progression, in which the ratios of any two adjacent terms, they yield a constant value. Finally, then we have an arithmetico-geometric progression, which is basically a combination of arithmetic and geometric progressions. So here 1, 4, 12, 32, 80 and 192, you can see that that 1 is increasing by a factor of 1 every single time, whereas the ratio that is constant here is 2, and you have powers of 2 multiplied next to it. Can anyone see a pattern here?
Could you please give the previous slide?
Previous
one minute.
Arithmetic.
Yeah.